As we look at these questions here that deal with electron configurations, really the most important thing that we have to know up front is how many electrons fit in each one of the shells. So this is what number 4 is asking us. So in the very first shell, there's always going to be 2 electrons maximum that one can hold. And so that's something that you're going to need to memorize. The second shell holds a maximum of 8 electrons. And then the third shell, for our purposes, we're going to look at that is holding 8 electrons as well. Now, the electron configurations, they do get a lot more complex, especially when you get to the third shell and above that. And if you start to take chemistry classes, then you're going to see that when you get to those. Now, according to the octet rule, how many electrons are needed in the valence shell to create a stable atom? Well, the valence shell needs to be full, and so the octet rule is really talking about them needing 8 electrons. And so that second shell, if there were 8 electrons in that, then that would be a full outer shell or full valence shell, and that atom would be very stable, and it wouldn't necessarily interact or react with other surrounding atoms. For number 6, draw the electron configurations of neutral atoms of each of the following. Okay, so the first thing that we really need to do, so kind of step number 1 here, is figure out how many electrons we're dealing with. And so once we know how many electrons we're dealing with, then we can actually draw those electron configurations. So to do that, you're going to need a periodic table, and you will want to look and see how many electrons will be in a neutral atom. So if we look at carbon, if I pull up my periodic table here, carbon has an atomic number of 6, so carbon is going to have 6 electrons. So I'm going to just write that here so I know that I have 6 electrons that I'm dealing with. The nitrogen, if we go ahead and look that one up, nitrogen has an atomic number of 7. So nitrogen is going to have 7 electrons that we'll want to put on its electron configuration. And then sulfur, it has 16. And then the last one, magnesium, if we look that up, notice that magnesium over here has an atomic number of 12, so that would be the number of electrons in a neutral atom of that. And now if we just go through and we actually draw the electron configurations for these particular atoms. So for carbon, if I'm looking at the one for carbon, carbon is going to have 2 electrons in the first shell, and those are going to be right next to each other. So we are always going to add electrons to the first shell before we start to add any to the next shell, which would be the second shell. So since we've added 2 to the first shell and put them right next to each other in carbon, now we have another 4. And when we put those in, we want to put 1 electron in each one of the 4 positions before we would start to add a second one in each one of those 4 positions. So that would be the electron configuration of carbon right there. If we look at the one for nitrogen, just move it up here. Nitrogen, again, so that's my nucleus. We want to fill the first shell first, so we're going to put 2 and we're going to put them right next to each other. Once that shell is full, we can add another shell, which would be our second shell. And again, we want to put 1 electron in each one of the 4 positions before we start to put a second electron there. So notice when we look at the valence shell that you've got 1 pair of electrons and then you've got 3 that are unpaired. It does not matter if your paired up electrons are on the top of the diagram or on the bottom of them, so long as when you look at the valence shell you see that there is 1 pair and there's 3 that are unpaired. If we look at sulfur, we're going to have the first shell with 2 in it. Then since that's full, we'll draw the second shell, and again we move around the circle, adding 1 in each position, then a second one in each position if we have that many electrons that we need to add. So now we've filled up the second shell and we've only used up 10, so we do have another 6, which means we need to draw a third shell on there. So now we treat that shell the same way we treated the second shell, and we'll start here at the top and move our way around, putting 1 in each one of those positions, and ultimately this is what we're going to end up with for sulfur. Okay, so sulfur has a valence shell that has 2 that are paired up, 2 pairs of paired electrons, and then we have 2 unpaired electrons. And then the very last one would be magnesium. And magnesium, if I just put it right here, magnesium, we're going to get 2 in the first shell. Then we're going to draw our second shell. moving around the circle, one in each position, then adding a second one there. So that has used up 10, and since we still have 2 more, we have to draw yet another shell there, and this shell we're going to put our other 2 in it. So that would be the electron configuration of magnesium. And the electron configurations, they're so important because if we can draw them and we know what they look like and what that valence shell looks like, then we can use that information to predict the bonding behavior of that particular atom.